Hi, this is Brandon, and welcome to the next video in my series on basic statistics. If you are new to the channel, welcome. If you are a returning viewer, it is great to have you back. If you like the video, please give it a thumbs up and or share it with classmates, colleagues, or friends, or anyone else you think might benefit from watching. So now that we are introduced, let's go ahead and get started. So this video is the next in my series on simple linear regression. And this video is about prediction interval bands. So in the previous video, we talked about confidence interval bands. So this one's about prediction interval bands. So remember, confidence interval bands are about the mean value of the dependent variable at a given value of the independent variable. This is about individual predictions. So we're gonna have two different bands on our graph. One's confidence intervals, that was the previous video. This one's about prediction intervals. So let's go ahead and get started. So this video is brought to you by the great people at the Great Courses Plus. So you are watching this video because you want or need to learn something. And as far as learning goes, there's no better place to learn anything you want, from cooking to philosophy to math to literature, than the Great Courses Plus. I've been a fan of theirs for years. So please see the link in the description below about how you can get a free trial to the over 10,000 video lecture library that they have. So click on that and you'll support the channel and of course support them. So let's go ahead and learn about prediction interval bands in simple linear regression. Okay, so this is the data we've been using all throughout this series. It is the bill amount and then the tip amount for a series of meals at a restaurant. Again, this is data I made up. So you can see the bill and tip variables over here on the right, and then the mean amount for each one, $74 for the bill amount, and then $10 for the tip amount. Over here on the right, and then the graph. So here is the regression equation that we generate when we do this regression. We have a slope of 0.1462. We have an intercept down here in the lower left. A centroid, which is the mean of each, we just said before, is 74 and 10 for each variable. And that roughly equates into interpreting it as, for every $1 increase in the meal bill, we would expect an increase in about 15 cents in the tip. Okay, so that relates to the slope over here on the right. So this is our regression equation and graph. So as I mentioned in previous videos, we're talking about estimators over many videos. I'm not going to go into each one, but we've talked about the other ones before. We are focusing on the second from the bottom, and that is the estimation or the interval for an individual value of y for a value of x. So in the previous video, we talked about confidence intervals. That's actually the one above it in this list. So confidence interval is about the mean value. Prediction intervals are not about a mean value of y, but about an individual value of y, which in practice might actually be more useful to us. So if I am a server at a restaurant and there's a party of 4 and the bill is $75, I want to be able to predict with some margin of error what the tip will be based on a bill of $75. And that's what we're going to do in this video. Not the mean tip for all bills that are $75, but for a individual bill that's $75. So again, just a quick review. Let's say you're the server who's been keeping data about meals and tip amount, which is actually something I would do because I'm a nerd. And then a table is a meal that costs $64. So based on the model we have, what dollar amount might the server expect for a tip? So if we're using our simple regression model that we had before, a good number might be $8.54. And we get that by just substituting in the bill amount of $64 into our regression equation, and we get 8.537. But again, I want to stress that this is not deterministic. If you have a bill of $64, it does not mean you're going to walk back to the table and the tip on the receipt is going to be exactly $8.54. We would never expect that because it doesn't work that way. But it's a good sort of rough gauge, but it's not good enough when we're talking about really understanding what regression is and does. So remember that the regression model is based off a sample, and that's the stats generated are just estimates. Another server would get different data. The same server on a different night would get different data for that matter. So regression is not deterministic. So for a meal that costs $64, a tip of $8.54 is just one of many possible tips. But we can develop an estimate based on intervals of what we might expect. Okay, we might expect what's the mean value of a tip when the bill is $64, and what is the predicted individual value or the range of values for a meal at $64. So we ask ourselves, what is the predicted tip, or more precisely, the range of tips we might expect for a $64 meal at this restaurant? So to answer this question, we will go back to sampling distributions. So we can't know an exact tip, so we will generate a prediction interval for the tip amount when the bill is $64. That's the best we can do, a prediction interval. So again, this note, it's important to realize that a prediction interval is for an individual value for a tip in this case, whereas a confidence interval is for the mean value. What we're going to find out is a prediction interval for an individual tip when the meal is $64. And you have to keep those two things separate. Many students that are learning this or whatever else get those two things confused. So this video is about individual tips. The previous video is a confidence interval about the mean tip. All right, so 95% prediction interval for y when x is 64. So I mentioned this in the previous video, but the notation is a bit overwhelming sometimes. And not only that, it's not consistent between textbooks and, and practitioners. You could pick up 5 different books and see 5 different ways of doing the notation. I'm using the one I'm familiar with based on the books I've used over the past several years. So here is our regression line on our graph. And we're looking at a bill that costs $64, okay, $64 meal. Now for this meal, $64, what would be our predicted tip, individual tip? So it could be any one of these circles here. It could just depend. On that point of the regression line, there's a distribution of individual tips. The tip could be $4, the tip could be $16 if someone's very generous, right? So we have this range or this interval of possible individual tips when the bill is $64. So you've probably seen something like this, in your software that you use, whether it's SPSS or Jump or R, Python, there's a zillion of them. Whatever you use, you might have generated an output like this. But what does this pink thing mean? Why is one of them dark pink and why is one of them light pink? Well, from the previous video, you remember that the dark pink there in the middle, that's the confidence interval. Whereas the lighter pink on the outside, further out, that's the prediction interval. What I want to point out here is a general rule. The prediction interval will always be wider than the confidence interval. So the confidence interval for the mean value of y is narrow, whereas the prediction interval for an individual value of y is always wider. So here's how wide that is. You can give the whole span of the entire prediction interval band when the bill amount is 64. And you can see from this graph that it's actually, the range can go from basically $0, $0, which is always a tip possibility, as anyone who's been a server knows, and then all the way up to $16. That's how wide our prediction interval is. That's a rough estimate, of course. So think about the curve sitting upright, pointing out of the screen towards you. So if you took this distribution curve and put your finger on the tip over here on the right, and then pulled it up, pointing at you, you'd have this distribution sitting on our graph here. So at a meal amount of $64, there's actually a distribution of predicted tip amounts that fall along that interval. So we're going to calculate the 95% prediction interval, which is the light pink span on this graph. So we're going to find out what this value way down here at the bottom is and what the value way up there at the top is. Okay, and we're going to compare that to computer output to make sure it all matches. That's what we're going to find in this video. All right, so I cheated, of course, and I did this in the computer software, and the answer to this is under that black square over there. So you can see that we have a bill amount of $64 over here on the left. We have the confidence interval for the mean. So what we're saying here, the confidence interval is that we're 95% confident that the mean tip for a $64 bill is between $5.26 and $11.86 for the mean value of a tip. Over here on the right, we're going to do an interval for the individual value of a tip. That's under that black box. So here is the interval for this predicted value. And again, I've said this, I think, in the past 3 or 4 videos. This is the standard form for an interval in statistics. So we used it in the last video for something very similar for the confidence interval band. We used it in the video before that, talking about the 95% confidence interval for the slope of the regression line. You have seen this form of an interval in confidence intervals for the mean, again, like 8 chapters ago. Same basic thing. So you have a predicted value of y over here on the left. Then you have this t of alpha over 2, sub alpha over 2, which is based on the t distribution, again, in the back of your textbook or online or on your cell phone app or whatever. Those two things you already have. They're very easy to come by. And then the third thing we got to find out is the standard deviation as to the prediction of that value of y. So it's the standard deviation of that interval. So the first two are easy. This third one we'll have to work on a bit to calculate, but it's not that bad. Okay, it's really fairly straightforward. Actually, it's very easy now that I think about it. So the first thing we know is that t alpha over 2 is 2.7764. We've been using that for several videos now because we're using the same data set. So degrees of freedom is n minus 2, which is 6 minus 2 in this case, so which is 4. Go to the back of the book. You look at degrees of freedom of 4 in the t distribution, and you'll see that 0.025 on each side. You'll have a t value of 2.776445. The predicted value of y literally comes from the regression equation that we had at the very beginning. Very easy. So we find that again just by putting $64 into the regression equation, and we get the y hat star over here on the left of $8.537803. So we go ahead and put everything else that we know in, and this is where we are up to this point. So the first two things are very easy. The S predicted, that's what PRED means, is the standard deviation of predicted value, is what we're going to find out. Luckily, it's very easy. So to find this value we need, it's actually fairly straightforward because it's just addition of two values we already have. So the combined variance for the prediction interval is really the sum of two things. It's the standard error of y around the mean. We already have that. It's in the regression output for you. And the variance of using y is an estimate. So variance because of using y star to estimate the expected value of y star. We already have this stuff. So two parts. The estimate of the mean value and also the values around the mean. We have a double variance situation going on here. And I will show you what that means visually here in a second. So for this prediction interval, we're really combining two variances. We're combining the variance that's related to the mean value of y, but also the variance within each one of those. And you'll see what I mean in a second. So visually speaking, so remember we have a mean value of our expected value of y. So here is our regression line. Now we can have a sample and the mean value of y can be in various places. You'll notice each star is at the mean value of y. So what that is our confidence interval. So a 95% confidence interval, and what we've been doing is the interval for these means, the means. But remember, within each one of those distributions, there are individual values. So now we got to put them together. So here's a regression line. Now we have the mean and we have individual values. Okay, so we do a sample, 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 so forth. Okay, this is not exactly where they were last time, but you get the idea. So now you can see where our combined variance comes from. We have variance within the confidence interval side of things. That's our stars. But then we have variance that's also due to like being within each one. And that's where our prediction interval comes in. So when we're looking at the variance of prediction intervals, it's actually a combination of two kinds of variance. The confidence interval where the star variance is in there, plus the individual values that are part of those. That's why we're adding together two variances. And I think this is a good job of pointing out why the prediction interval is always wider than the confidence interval. One's for the mean, one is for individual values. Variance within variance. Okay, back to math. So we got to figure this out. 2.742029 actually came from our regression output. It's the standard error of the estimate or the root mean square error, depending on whatever software you're using. It could be something else. Who knows? And then we got to figure out this s squared over here on the right. And the good thing is we already have it. Guess where we have it from? We have it from the confidence interval calculation in the previous video. All we got to do is square each one of those two things we already have and then add them together. So we square each one and we add them together. So that's our equation there. Square, add, and here we go. So we have our variance there of 8.950606. So we can take the square root of that to get just S prediction, and that is 2.991756. So now we go ahead and put everything in. So that's what we had before. We just found our S, which is a 2.991756. Do some multiplication. Now we're almost at our interval that we're looking for. Do the plus or minus, and there is our prediction interval, 95% prediction interval for y hat star, or for y, when the value of x is 64. So that's our prediction interval. 0.231356 and 16.844250. That's our 95% prediction interval. So a regression line again, our x is 64. So we have a distribution kind of sitting on top of that. So our prediction interval at its low end is 0.23 and change, and then on the upper end is 16.84 and some change, and that is our prediction interval. And lo and behold, there it is. So on the right we have a black rectangle around those values from the computer, 0.231356, 16.84425, and then here is what we did by hand, 0.231356, 16.844250, the exact same. So we know we are doing it correctly. Okay, so the 95% confidence interval and prediction interval for y when x is 64, we're going to put them on the same graph. So first, the confidence interval. This is from the previous video. So here is our confidence interval, so the boundary of it. It was 5.21, 11.86. Now let's put on the prediction interval points. So way up there at the top is 16.844. Down here at the bottom is 0.231356. So that is the boundary of our prediction interval. Okay, so you can see the difference. Confidence interval, prediction interval for the same value, in this case, 64. So what if we put it all on one graph? So here we have the lower confidence interval, then we have the upper confidence interval, and then our predicted tip, or our regression line, basically. Now we have the prediction interval. So we have two confidence intervals and the regression line there. Now we have the lower prediction interval and the upper prediction interval. Okay, so you can see the pattern. It slightly bows out towards the ends in the same way the confidence interval does. And that's for each value of data that we have. And this is what the computer output looks like. So this is the computer output of the graph we just did on the previous slide. So the dark pink is the confidence interval and the light pink is the prediction interval. So remember, again, this is from the previous slide, but because the confidence interval is built in to the prediction interval, it follows the same pattern. It's going to flare out slightly at the ends because this value is built in or baked in to the prediction interval. So the estimated variance for both sources of variation, is that it's minimum at the mean of the independent variable. So the mean of the independent variable in this case is 74. So if the value we're interested in, or the meal we're interested in, is $74, 74 minus 74 obviously is 0. So this whole equation gets minimized or kind of reduced to this smaller version. And therefore, the confidence interval and the prediction interval are both at their most narrow at the value of the mean of the independent variable. In this case, is $74, because they're kind of intertwined. So we can deduce, and this is important, that the most precise prediction for y is at the mean of the independent variable. So our predictions are better for meal amounts that are around $74. As we get away from $74, our predictions have much more variability. So as x star gets farther from x bar, the confidence and prediction intervals will become wider. So always know that the confidence interval and prediction interval are at their most accurate around the mean of that independent variable. This video is brought to you by the Great Courses Plus, where you can get unlimited access to over 10,000 different video lectures taught by award-winning professors from the Ivy League and other top schools around the world. You can learn about anything that interests you, science, literature, and yes, statistics, like this lecture from Professor Talithia Williams called Linear Regression Models and Assumptions from her course, Learning Statistics, Concepts and Applications in R. And right now, the Great Courses Plus is offering my viewers a free trial and is now also optimized for Australia and the UK. So go to thegreatcoursesplus.com/Brandon Foltz, my name, to have access to the 10,000 video lecture library, or click on the link in the description below. Okay, so that wraps up this video. It's probably a rather long video, I apologize, but to get it all in, you got to get it all in. And to make the visuals, it takes a little time to explain it. So that was our video on prediction interval bands in linear regression, simple linear regression. So I hope you found this video helpful and even more important, insightful, so you understand where it comes from, what it all means, how to do it by hand, how to do it by computer, and how to visualize it. So you really get a sense of what is going on in linear regression. So if you stuck with me, I really appreciate it. Thank you very much for watching. I look forward to seeing you again in our next video. Take care.